Hey, I'm Idan Schwartz, a PhD candidate from the Technion. My advisors are Professor Alexander Schwink from UIUC and Professor Tamir Khazan from the Technion as well. The goal of the visual dialogue task is to build an AI agent that can hold a meaningful dialogue. That is, our agent needs to generate an answer given an image, a question, and a history. In this example, we are asked, are kids wearing hats? Our agent answers 0 of them. But how do we assess the correctness of this answer? Well, one approach is to use generative metrics. Those metrics capture correctness by correspondence between a human and a machine. However, those metrics rely on syntax. For instance, this example is must be correct according to generative metrics because only one word is different. In a dialog setup, we care more about the semantics. To focus on semantics in the discriminative approach, we choose an answer from a candidate. However, there is an issue. What if there are multiple correct answers? For instance, another annotator chooses to pick no as the correct answer instead of 0 of them. For that, we want our bot to recognize all the correct answers. This ability is evaluated with the NDCG metric. We ask various annotators to pick up any correct answer to create dense annotations. The NDCG metric checks if our model ranked high all the correct answers. But there is another issue. We want precise answers and not vague answers. Here we prefer an answer that tries to estimate the kid's age to be 4 years old. To this end, we use sparse annotation. We ask a single annotator to pick up single most accurate answer. The MRR metric checks the rank of this answer. We want to perform well on both MRR and NDCG. We propose a method to ensemble a model that is good on MRR and a model that is good on NDCG. Our ensemble ranking improves the MRR score while keeping most of the NDCG performance. For a good MRR model, we use factor graph attention, namely FGA. FGA generates an attention map for each utility separately by letting all the utilities entities interact. For instance, words in the question with words in the history, with answers, with image regions, and so on. FGA relies solely on the sparse annotation. This allows a state-of-the-art MRR score, but mediocre performance on the NDCG metric. The NDCG model is the VHDL Belt. This model pre-trains a VHDL Belt model on related vision language datasets, such as conceptual captions and visual question answer. Also, it fine-tunes directly using the dense annotation. Therefore, it achieves 74% on the NDCG metric, but only 50% on the MRR. So what is our approach? MRR is based on a single answer. First, we find a minimal set that hold this answer. The way we do it is by training multiple MRR models with different initial conditions. We find candidates by looking at the top answers of those models. We keep only candidates that are either highly confident, that means that all the MRR models rank them high, or candidates that agree with the NDCG model. We rank this set using the MRR model, and we rank the remaining candidates according to the NDCG model. Let us see an example. Here the question is, what is the nightstand made of? This question is hard to determine, even for humans. Still, the MRR top answers exhibit more visual understanding. For instance, they mentioned covered in cloth, it appears to be a large red pillow, while the NDCG top answers, although they are not incorrect, they are very vague. To ensemble both of them, we first create a minimal MRR set that is likely to hold the correct answer according to the sparse annotations. We train several MRR models with different initial conditions. We keep only candidates that are ranked high according to all the MRR models. Also, we keep candidates that are ranked in the top 10 by the MRR models and also in the top 10 by the NDCG model. The intuition behind that is that these answers should not harm the NDCG metric, so we don't mind keeping them. For our final ranking, we first rank the MRR set according to the MRR model and the remaining according to the NDCG model. This is the result table. Again, our approach improves the MRR score to 70% while keeping most of the NDCG score. Thanks for listening.